Welcome to Around the Drafting Table, where we talk about topics that are top of mind for homeowners looking to design a new home. I am Kory Cox, the Oxford architect. Our topic today is mechanical and plumbing engineering, another member of the design team on your custom home journey that can have an impact on your long-term enjoyment and comfort in the home. Joining us today, we have Garrett Sorensen from Royal Engineering, where he focuses on mechanical and plumbing. Garrett, thanks for joining us today.
Glad to be here, Kory.
Jumping straight in, would you like to briefly talk about your experience and how Royal Engineering tackles high-end custom home design differently from other typologies that you work on?
Yeah, so a little bit about my experience. I've done a fair amount of residential. I've done a lot of commercial. And one interesting thing about the high-end residential market is there tends to be some overlap with the commercial side of things when we
Hmm.
get into things like, pools and large sports courts, things like that. And so that's kind of some overlap I see between the commercial and residential side. And that's also what makes custom homes unique, right? That they're not just a small home, they're a large home, they have
Hmm.
custom elements to them, and it definitely makes them unique from other types of projects that we work on.
Great. One oddity of your discipline is that you handle two, both mechanical and plumbing. You're the only member of the extended design team that performs a dual role. Why are these two specialties combined into one, and how do owners benefit from this arrangement?
I think the biggest reason is both disciplines handle the flow of things, right? So mechanical, the HVAC system side, handles the
Hmm.
flow of air around the building, and then the plumbing system handles the flow of water. And in some mechanical systems as well, there's also water involved. And so there's a lot of crossover, and on some HVAC systems, there's pumps, and it may even be the same pump that's recirculating your hot water for your um, hand washing drinking water.
Hmm. Yeah, so it's one science, really. It's all fluid dynamics, right?
Exactly.
All the
Yep. A
same
lot.
calculations and on both sides.
Yep. It's the same principles, just applied in different ways in different places.
Perfect. Tell us about a custom home project that you've been working on recently. Can you share any project details or outcomes?
Yeah, I probably won't say where it is or who it's for, but I
Hmm.
have been working on a big 30,000 square foot custom residence. It's quite unique. It's got a large sports court area. It has a multi-vehicle garage. I think it
Hmm.
has like 14 vehicle stalls,
Okay,
if I recall correctly.
pretty big. That sounds more like a toy chest than a garage.
Yes, that does sound like what it is, and it's probably what it's intended for. So
Hmm.
it's definitely one of those where there's a lot of commercial elements to it. There's kind of a residential home space in the building that is
Hmm.
maybe more of what you think of with the home, but obviously the parking garage and the sports courts, those definitely have more of a commercial element to them.
Yeah, for sure. Um, so how do you take a home from 10,000 square feet to 30,000? You mentioned it has like sports courts. Is the garage included in that number? Or what other
Yeah,
amenities do they have?
the garage, well, I guess I should be more exact. The total square footage of the building is 35,000, and I believe 8,000 of that is the parking garage. So
Okay.
there's 27,000 square feet of livable space, and I think maybe in the neighborhood of 10,000 is kind of that sports court amenities area.
Okay. Okay. So that's pretty much half of it between the parking and the sports fort.
Yep.
Yeah. Still leaves a very large home. And I'd be certainly interested to see what that looks like myself. What would you say on a home like that are some of the highest priorities in mechanical design?
That's a good question. I think obviously the biggest priority is safety, right? Making sure that everything's code compliant, and that's kind
Hmm.
of our baseline, right? The next most important thing is comfort because that's the whole purpose of the HVAC system.
Hmm.
If people aren't comfortable, then it doesn't really matter what else we've done. We've
Yeah.
failed in our objective, right? After that, I think the biggest priority is probably lifetime cost, as far as things go. So
What is lifetime cost for someone who might not have heard that term before?
Yeah, lifetime cost is looking at the system and taking into account all the different um, aspects of the cost. So you have like first cost,
Hmm.
you also have the maintenance costs, the operating costs. So, for example, um, maybe you come across somebody who says, "Hey, I can sell you this really high-end system. It's really cool. It'll, keep your house super comfortable." And, maybe that's right, but that's going to be pretty expensive. The maintenance costs might be higher. It might be more difficult to maintain.
Hmm.
And because of that, it's going to have a higher lifetime cost,
Yeah.
where you might have been able to get similar performance with a lower end system, um, kept you just as comfortable, but for a lower first cost and for a lower maintenance cost.
Yeah. Do you also include replacement cost in that?
Um, it depends on the lifetime we're looking at. If we're looking at the lifetime of the building or the
Hmm.
lifetime of the system, I think
Yeah.
most homeowners are probably interested in the lifetime of the building. And so, yeah, the system replacement cost would be included in that.
Yeah, because if you're looking at a very low cost system, I mean, maybe it's a third of the cost or half the cost to install, but it only lasts half as long as a better system.
Yep.
It might be worth that initial upfront investment, understanding, especially, 10, 15 years go by, you need to replace your equipment, and inflation will have doubled the price of that equipment. So investing in equipment that lasts a long time could be a very worthwhile investment.
Yep, that's correct. It's something that's definitely worth looking at.
Mhm. Okay, you mentioned comfort. What are some of the most important aspects of comfort? What do you do to ensure that each individual space in the home maintains a comfortable temperature, particularly like, my bedroom faces south and gets overheated all summer long. How do you handle that?
Yeah, that's a really good question. And once again, this touches on the cost end of things. Um, but we run into a problem called zoning when we're
Hmm.
designing HVAC systems. And so we could, let's say we have a smaller home, right? And this home has a central furnace with an air conditioning unit. So you have one thermostat, and the problem is that, like you said, with your bedroom, it gets a little bit hot in the summer.
Hmm.
Whereas on the other side of the house, maybe it's getting over conditioned and it's getting cold.
Yep.
There are ways to overcome this, but the price increases as you start to address this. One way um, is having smaller zones, but as we do that, you add more equipment, right? So that makes it
Hmm.
more expensive. Um, Mini splits, those are a good approach to use. We use those a lot in commercial settings, but I know
Yeah.
they're not the most popular aesthetically, though there are types that you can conceal and things like that. So, more localized control is kind of what we go for to overcome the issue of hot spots and cold spots.
Hmm. I think zoning is a very interesting thing to talk about. It has more aspects to it. So, like in this 30,000 square foot home that you're working on, um, do you have a zone for the sports courts and a zone for the garage, and then multiple zones within the residential area? Um, and what's the purpose of that? What else does that accomplish?
Yeah, that's correct. We look at different uses for sure. So the sports court is completely separate from the rest of the house as far as conditioning goes.
Hmm.
Um, Actually, touching on another residential job I did not too long ago, we had the master bed and the master bath just on their own heat pump system.
Yep.
And because, you want the master bath and the master bed conditioned to the set point that, the owner wants it to be conditioned to.
Hmm. Hmm.
So that was one approach there. Then we had, the rest of the house zoned. So like the kitchen was on its own zone. We had a couple of like the guest bedrooms together on a zone. Um, so they're smaller units, more smaller units, but they're able to give that localized control. Other
Yeah.
ways that people do this, if you have a larger home and you go with a VRF system or something like that, you can have large outdoor equipment that serves smaller indoor zones. There's also hot water and cold water systems that
Hmm.
can do the same thing. But once you get into those, your costs are going to start increasing.
Sure, for sure. Another one of the purposes of having separate zoning for separate uses is to ensure that you're not having air changing between incompatible zones. You certainly don't want any air from the garage getting into the bedroom spaces.
That's correct.
Yeah. Let's pivot then and talk a little bit about plumbing. What are the highest priorities in plumbing design?
The biggest ones, we want nobody to notice the plumbing. I think that's the best way to put it. We
Hmm.
want the toilet to flush when it's supposed to flush, no sewage backups. We want everything to drain properly.
Yeah,
We want there to be adequate water pressure everywhere. And then we want hot water to be delivered in a timely manner to the different areas of the home. So, um, if you turn on your hot water on your faucet, I'm sure you've been in the situation where it takes, 30 seconds to get there, and that can be
or
quite,
more.
or
Yeah.
more. Yep.
Even in my small home, it can take up to a minute to get hot water to the master bath.
Yep. Yeah, I have the same situation, so
Hmm.
it takes a long time. That's obviously wasteful for the water.
Hmm.
It also is something that's annoying to deal with.
Sure.
So,
There are multiple ways of handling that. Yeah, I mean, two come to mind for me. Like one is a recirculating pump, and then the second would be point of use water heaters.
mhm. Yep.
Um, have you ever used point of use water heaters, or what's your highest recommendation there to solve that problem?
Yeah, we use both of those approaches. It kind of depends. With point of use water heaters, one big consideration is they're usually electrical, right?
Hmm.
And electrical water heaters tend to have a high electrical load, especially the instantaneous ones. So there's some consideration there as far as your electrical load goes.
Yeah,
I would never recommend that you put your shower on a point of use water heater. I would only do like a hand washing sink. That would be the biggest I'd go because once you get larger than that, the amount of electricity required to heat that water becomes very large, and it's going to start driving up electrical service sizes, panel sizes, things like that.
sure, sure. And is that if you compare it just to like a gas tank storage water heater, or even if you compare it to like a central electric instant water heater?
Yeah, yeah. I'm not a big fan of central electric water heaters.
Hmm.
They just draw a lot of power, and you can
Okay.
plan for it in the design, right? But it is going to increase your electrical service. Um,
Okay, so I mean, what I think what I'm hearing, and tell me if you think this is true, is if you're heating water electrically, it's going to cost more,
exactly.
whether you're using point of use or central. But for owners who are interested in having an all electric home, it's basically the only option, right? And so it just has to be planned for from the start to ensure that the panel can handle it.
hmm And if you do go with an all-electric home design, I would suggest using an electric tanked water heater, something that has storage, because as you have some storage, you can kind of even out the spikes of power needed
Hmm.
to be able to heat that water. You can think of instantaneous water heaters like a fire hose of electricity,
Okay.
whereas a storage water heater uh, uses a garden hose of electricity, right? And you have to fill the same container, but you have you do so in a shorter amount of time with the instantaneous water heater. So you end up, pulling a lot more water, a lot more energy through that hose. You have
Hmm.
more
Hmm.
time to put that energy into the water with the storage heater, so you can have a lower electrical size.
Yeah. I think this would be an interesting discussion with the electrical engineer, who I think I'll be having on a future episode of the podcast. So I think I'll tag that into our discussion for that one, and hopefully our listeners can join in then.
Yes.
What are some challenges you regularly face on high-end custom homes, and how do you overcome them?
I think the biggest challenge that we have on custom homes is an issue of space,
Hmm.
especially with mechanical systems, right? Because ducting is, obviously it takes up space. Boilers take up space if you have a snow melt or a radiant system,
Hmm.
and air handlers take up space. I'd say that's the largest thing. So being able to coordinate the space required for systems with the aesthetics desired by the owner, and coordinating with all the other systems in the home as well.
Hmm.
That's our biggest challenge by far.
Yeah. And there's always pushback, right?
Yes.
I think on every project I do, at some point, someone asks the question, can we make the mechanical room smaller?
Yes. And I think we
Always a
we hear the
desire.
same thing. Yep.
Yeah. Mechanical systems are frequently quite confusing for homeowners, like heat pumps, VRFs, mini splits. There's a lot of acronyms, there's a lot of specialized language, and many options to choose from when selecting equipment. How do you approach that conversation with homeowners in an easy to understand way so they can make a well-informed decision without being overwhelmed?
That's a good question. I think it's important for, like you said, first of all, I think it's important for the conversation to happen because I'm not sure it happens all the
Hmm.
time. For the owner, the architect and the engineer to sit down or, meet over a video call and discuss the options, right? The engineer has a rough idea of what the costs of these systems are going to be,
Hmm.
their advantages and disadvantages. Um, I think for me, I try to explain it in terms of things that owners, are more familiar with. I would imagine most homeowners are familiar with simple gas furnace air conditioning systems.
Yep. Hmm.
And really, in the business, there's only a few basic types of equipment. So there's stuff that uses the refrigeration cycle, so like an air conditioner or heat pump. There's stuff that burns gas, and then there is stuff that uses electricity to heat. So we were talking about electric water heaters just barely.
Hmm.
There's also electric strip heaters that can be put in ducts to heat the air, things like that. So whatever systems are out there, there's some kind of a combination of those technologies. And they have their advantages and disadvantages. So just walking them through um, those systems in things that maybe they're already familiar with, I think that is the most advantageous way to approach it.
Okay, great. There's a trend of building homes with electric only service, so no natural gas or propane for heating or water storage, as we talked about already. Is there an energy efficient way to heat a home so that this decision does not lead to very high bills during the winter months?
I would say it's very difficult to achieve. It's hard to replace gas. Gas is extremely energy dense, and you
Hmm.
can get a lot of heating out of a small amount of gas. So I would also say it depends on your climate. If we're in St. George or in Phoenix or something like that, we can probably get away without gas fairly easily. Um, but if you're in Park City or another alpine area,
Hmm.
um, you can probably expect a fairly large electricity bill during the winter because, like I said, in the previous question, your heating has to come from, one of those three things. Either it's coming from gas, it's coming from electricity that's being, I guess we could say burned,
Hmm.
um, through a resistive heater, or you have to use a heat pump.
Right.
Now, if you are doing electric only, the best option is to use a heat pump.
Hmm.
Um, that being said, heat pump performance tends to drop off the colder you get. So it's unfortunate, but heat pumps heat really well when it's hot outside, and they cool really well when it's cold outside. So I think heat pumps are definitely the route to go. But if I were the owner, I would definitely consider having some kind of backup resistive electric heat as well to make sure that things don't freeze in the winter if something were to go wrong with the
Yeah.
heat pump.
Or perhaps you'd pair it with a radiant floor heat.
Yes, and there are electric radiant floor heat panels that can be used.
Yeah.
If you do have a radiant system, though, I would say 9 times out of 10 it ends up being gas because that's the cheapest way
Yeah.
to get the water heated up.
Yeah. So actually, I was curious. I do know that there are kind of multiple kinds of radiant floor heat, and usually we do a hydronic system that is embedded in a concrete substrate. But I have seen the electric panel ones. So my assumption is the electric panel ones are pretty inefficient and really not a very good system. But what's your opinion on that?
Yeah, I agree with you on that. If you have to use them because there's no gas available, then we need to use them, right? If
Hmm.
radiant heating is desired. Um, However, it's one of those types of heat that, just burns the electricity. So I
Right.
put in 1 watt of electricity, I get 1 watt of heating. Whereas with a heat pump, if we had a heat pump air handler heating that space, I could get maybe 2 to 3 watts of heating for every 1 watt input. So
Okay.
it's going to be quite a bit more efficient if we use a heat pump system in that case.
Yeah. The hydronic concrete embedded radiant floor heat, I think, is the system that we see in all the high-end homes. The electric panel radiant heat, I think I mostly see that advertised as a renovation item,
Mhm.
or perhaps for just a couple of spaces. So we already touched on this topic. In every project, inevitably, there is a question about reducing the size of the mechanical room. How big does a mechanical room need to be, and is there a strategy an owner can take in equipment selection to eliminate this room altogether?
Yeah, that's a great question. I would say it depends. Uh, the first thing I'd ask is, do you have hydronic radiant heating? And
Hmm.
if you have hydronic radiant heating, you need an equipment room
Yeah.
for sure. There's not really any getting around it because you need space for the boilers, you need space for the pumps, space that you can go in and maintain the system. In a room like that, I would say the minimum dimensions I would consider would be 10 by 10. Um,
Hmm.
of course, I'm a
Well, it depends
mechanical
on
engineer,
the
so
size of the home as well, right?
exactly.
Kind of
But if
scales.
it does scale, the larger the home is, the larger that room's going to need to be.
Yeah. Or perhaps multiple rooms. So you can gain some efficiencies in the distance from the equipment to the area that it serves.
Yes. Um, I I think for hydronic, it's pretty easy to serve the entire home, even if it's a large home, off of one mechanical room. You're going
Hmm.
to have a bit more energy put into the pumps at that point to pump the water throughout the house. But where we really run into trouble is with the air side equipment. So if you have air handlers that are doing your cooling in the summer
Hmm.
and doing some supplemental heating in the winter, I think that I've seen a couple projects where they've wanted them all put into one mechanical room. And I think that's a bad idea, and here's why I think that. We have to get ducting out of that room,
Yes.
and ducting takes up a lot of space.
Hmm.
So we get to play a really intricate game of Tetris with all that equipment, trying to get those ducts out, and then they've got to be installed in the field, and it doesn't work out very well. So what I would recommend as far as airside equipment is I would have multiple smaller mechanical closets scattered throughout the building um, that can kind of serve their individual zones. Now, you could do that with a closet air handler. You could do that with a ceiling concealed air handler. You could put an air handler in a crawl space if that's something that's available in your
Hmm.
home. But I would definitely have mechanical spaces throughout your home. One other consideration, I'll just throw this in. I just remembered a lot of high-end homes have large kitchen exhaust hoods.
Yep.
And once you
And
go
perhaps
over
open fireplaces.
open fireplaces, things like that, with kitchen exhaust hoods, once you go over 400 CFM, the code requires a makeup air system
Hmm.
so that you don't depressurize the house. Um, you want to plan a mechanical room relatively close to your kitchen if you have a large exhaust hood,
Yeah.
so that you can duct in makeup air.
Yeah. So, I mean, you mentioned that it's required by code once you go over 400 CFM, which is kind of a low bar. That's
Yes.
a small kitchen hood. And so I think owners can expect to see that system in the home. But what happens when you depressurize a home? Why is that required?
So One thing you might notice is that doors become hard to open, or if they swing inwards, they become very easy to open, kind of
Hmm.
fly in. I'm sure everyone's walked into a restaurant at some point where the door is hard to open. That is the result of building depressurization.
Yeah.
There's a couple other negative effects of that. One is you start infiltrating a lot of air through the building envelope, so through the walls and the cracks around the windows, all of that.
Hmm.
And that's
Areas that
going
we
to,
do our best to try and seal everything, but it's never perfect.
exactly. So it starts drawing air in there. If it's a bad air quality day, we're bringing that air into the building without being filtered. And we're also adding, all that load, heat load into the
Hmm.
building. So it's going to increase your costs to condition.
Yeah.
All in all, just a bunch of small negative things
Yeah.
around
Oh, and all that
depressurization.
air coming in is also bringing moisture with it.
That's
And that
correct.
moisture is being deposited inside the walls. So we built walls in such a way that they are able to dry out if there is moisture present. That's very important. But we want to ensure that we limit any moisture that gets into the wall in the first place. So the make a fair system, even though it's an extra expense, is very important.
That's right.
Yeah. So we talked about ducting quite a bit, and I think everyone understands what ducting is, and that it's, very large. How would you create a system that didn't have any ducting, or perhaps only had very small ducts?
Yeah, so there's a couple options for this. One small ducting option that I have seen, I haven't used it personally, but I know that there's a brand, I believe it's Unico. They do a small high velocity duct system.
Hmm.
So you make the air go really fast, and that allows a larger quantity of air to go through a smaller duct. Now,
Yeah.
these ducts have to be special. They have to be insulated so that the sound from all the air moving doesn't make it sound like you have a river in your ceiling.
Hmm.
Um, so they're easier to run, but there's also a cost associated with that, in addition to it being more specialized equipment. So it may be harder to find someone to work on it in the case that it does fail. Another option is with mini splits, or if you have a VRF system with, the heads of the VRF system. There's some options there that don't have ducting.
Hmm.
Some of them, people don't like because they're not really aesthetically pleasing, like the wall hung ones.
Right.
Um,
Yeah. The ceiling ones are definitely better, but still visible.
Yes, and that's the trade-off because they have to fit, everything into that little space that they have, whether it's a ceiling cassette or a wall-hung unit.
Hmm.
They may not be the most aesthetically pleasing, but those are kind of your options if you don't want to use ducting.
Yeah. I mean, so with either of the, well, more the second option, um, is it's probably still wise to have an air handling unit bringing in fresh outside air, perhaps just 5%, piping it through a low velocity 3 or 4 inch round duct to each room in the home just for fresh air. Is that true?
Yes, that's correct. No, we definitely want to have fresh air in the home, and most ceiling cassettes, not really wall hung units. We don't see it with wall hung units, but ceiling cassettes tend to have a small knockout that you can duct
Hmm.
fresh air to, so you can have some amount of fresh air entering the space.
Yeah. So, if you're working on a home that has a very constrained ability to have large ducts going, this way and that, concealed in the ceiling spaces, there's definitely a way to accomplish comfortable spaces with fresh temperate air without all those ducts.
That's
Good to
correct.
know for everyone. So we talked about a lot of different kinds of equipment. What would you say is the cheapest equipment to install, and which equipment is cheapest to run long term and including their expected service life before replacement?
Yeah, kind of hard to give a blanket answer on this one. I would say, as far as first cost goes, it's going to be your residential furnace air conditioning
Hmm.
systems, right? And probably the
Very
next
standard equipment.
very standard equipment. After that, probably heat pump systems. So,
Hmm.
no gas there, but they do heating and cooling, but it's kind of the same system. They're very similar. After those, you start getting into the more I don't know if niche is the right word, but the more specialized systems. So or you get closer to commercial stuff, I should say.
Yeah.
So things like VRF systems or our hydronic radiant systems, those are definitely going to be, a lot higher as far as first cost goes, and there are
Yeah.
additional maintenance items associated with those.
Yeah, I mean, particularly talking about a radiant system embedded in concrete, the weight of that concrete has to be calculated into the structure. So there's kind of a cascade effect. It's not just the mechanical system. We also have to have heavier structure to support all that weight. So um, that's all part of the consideration.
Yep, that's correct. And you also, are kind of expected to maintain a certain water quality in your hydronic system as well, so that there's
Mhm.
no corrosion happening in the boilers and in the pumps and in the pipes. So there's an additional maintenance cost there as well.
Yeah. Okay. Perfect. Is there anything else that you'd like to add about the importance of working with a mechanical and plumbing engineer in home design?
I will say, honestly, I think there are circumstances where you don't need to. And I would say those circumstances are if you're on the smaller end of
Hmm.
a custom home. If you get above maybe 7 or 8,000 feet, I think, or square feet, excuse me, that's probably where you're going to want to start looking at bringing on an engineer. And if you have anything that's more on the commercial side, so like an indoor sports area or an indoor pool,
Hmm.
please bring on a mechanical engineer so that they can help you design your system and protect your building. Pools especially. You don't. I'll tell you a story about a hotel. Um, that I won't tell you what town it was in because that would tell you what hotel it is.
Yeah.
But they didn't have a proper HVAC system for their indoor pool, and after several years, the ceiling started to fall in because of the humidity issues.
Yep.
And there's all sorts of other kinds of damage that can come because of pools. So indoor pools, if you have one of those, please talk to an engineer.
Yeah, because not only are you dealing with moisture, you're also dealing with chemicals being
Hmm.
carried by that moisture. So mechanical system specifically for the pool, highly specialized and very important.
Yep.
Okay, perfect. That's our time. Garrett, thank you for joining this conversation around the drafting table today to provide your thoughts on mechanical and plumbing engineering. And until next time, get in touch with Oxford Architects so we can dream together.
Thank you, Corey.